We will have Shuichi Ihara for Lustre Performance Evolution, Mastering Challenges through IO500.
Shuichi Ihara, Principal Engineer at DDN and Web Cloud, boasts over 15 years of dedicated experiences in the realm of Lustre file system. His primary role is focused on I/O benchmarking and optimizing Lustre storage system. Shuichi is well regarded for his involvement in large-scale Lustre deployment and his expertise for delivering advanced Lustre solutions with innovative features and capabilities. His proficiency in Lustre has been contributing to the Lustre community.
Thank you. Hi everyone. So this is the final presentation today before the social event. I want to share. So we started the IO500 testing on over 5 years ago. Then I want to share our achievement, then where we are. So I/O benchmarking. So when you consider new storage system on your new HPC cluster, so the performance is one of the critical requirements on the system. So I/O benchmarking is the playing the role to understanding the performance, also the selecting the right storage solution, your cluster. But I/O benchmarking is always challenging. So there are a lot of the methods. There are a lot of the tool. So they also you have to consider. Typically, new system is the first, faster than the old system. Then you also very interested in the new storage system is you also looking interested in how other system storage system is the performing of your close of your system. So in order to standardize I/O benchmarking, so IO500 was created 4 years ago, or no, maybe 5 years ago. So the tool was more easy to use to run. Then also the assessment, it's easy to the assessment of the I/O bandwidth under the metadata operation under the search. So tool is dividing to tool. To test on the easy, the hard, it's hero, one of the anti-hero testing. So in the end, so you can get all the performance result. Then then eventually the score is calculated from the result. So that's the result is the comprehensive evaluation. So it's not the much. It's to avoiding the single performance. It's one of the outperforming the performance number. The other interesting stuff of the IO500. So if you want, so you can send the result to the IO500 community. So the community review on your result. Then so the community the release of your result on the list. So the list is always, list is updating every two times every year. It's the same idea of the other, as a top 500 or the green 500 list. So IO500 has a different category, number of the category. So the production on the research, non-production. Then full list, so regardless the how many the clients that participated to run, or list only limited to 10 clients. So you can run IO500 on the cloud, the on-premise, so it doesn't matter. So you can this allows the made flexibility to run on the participating test result to the to the list. As you know more the IO500 already, but let's just reminding the more deep into what IO500 is doing. So again, so IO500 composed the two part of three the benchmark tool. So one is the IOR, then MD test and the find. So IOR, the MD test, divided as I said before, divided the easy and the hard the testing. The IOR easy, that is general the file per process the workload. Then you can select the IO size that you want. Then IOR hard, so this is a single shared file. Then the fixed IO size for 4700 8 byte. It's a non-aligned IO. So MD test easy. So this is all the process conduct to run the metadata operation the individual directory. Then all the file size is 0 byte. So MD test hard, so this is the harder operation to the file system. So it's a one single shared directory is there. Then all the MD test the process the participating to the one single shared directory to operate the metadata operation. Then this is not 0 byte file. This is a small file, the 3901 byte. So finally, there's a find operation. So the find operation, you have to find 3901 byte the file from the old created file by IOR the MD test. Then you have to print the how many the file that match the of the find. So the find allows to use the external command. So you can use the find command of the the MPA util or the pfind. So whatever. So you can use any the tool. So in the end, so you the score the bandwise score calculated by all of the IO world result. The MD test is also the so metadata score is also the calculated by MD test result. So both of them more geometric than mean. Then eventually, so you can get the final score to the publish. So all of them, the score can be the published. Then so that is a IO500 rule. So the other rule, so no much the detailed rule, but one of the other rule, one of the critical rules. So you have to write the minimum of 5 minutes. Then all the data have to store on the persistent storage devices, not the memory. Then also IOR IO500 avoiding the client caching. So this is the option is there in MD test IOR. So it's striding the MPI lang. So the next metadata or IOR operation can be the avoiding under the client caching. So that is IO500. So what's our motivation of IO500? So the company is always wanted to publish. IO500 result as a marketing number, but that is not our goal actually. So we are not going to be the top one result. So if we can invest a lot of the money, so you can make the good score. But what we wanted to do of the IO500, it's we want to show how we can improve the performance each of the time. The other thing, there are a lot of the benefit, a lot of the run. So we through the IO500. So this is we also are using that tool, the one of the performance regression testing before the release of Lustre. They also this is determine the I/O workload. So that's much easier to the tracking or the keep the record, then also the publish the result as well. Then also, of course, the IO500 list. So this is a good place to see. Everyone can see, what's the best performance. What's the best performance on the configuration? So you can more easy to access the best performance of the storage system on the list. The other opportunity of the IO500, so as I said, so there is a 10-node list challenge, a 10-node challenge of the list. So that is the interesting opportunity to run because of this is the more how we can get the maximum of the performance by a small number of the client resources. How we can maximize the performance efficiency of the small amount of the client. So typically HPC system. So the many clients that access to the one storage system to get the maximum performance. So that's easier. But at the other side, so the AI or the machine learning, so they have a very large client. So each client has a 2 socket on the 8 GPU on 2 400 gig infinite band network. So we have to think about how we can get the maximum of the performance from that's the type of the single client. So we need to think about that's the performance efficiency for the 10-node challenge. We also a lot of the stuff is learned from the IO500. So not only just Lustre, but we have to check. We have to understanding where the bottleneck is on the storage system or Linux kernel or network. So overall, right? So we have to we need to we have to understanding the more structure of tracing capability of the performance. So that's the experience very helpful on the not only just around that testing, but also that capability is very helpful identify the real customer the problem at the customer side in the production. So the sort of experience is also the help not only the IO500 but also the real world. So in order to do that, so we added the I/O tracing the capability. So this is also the this is also the good. So this is it's already available on the Lustre upstream. So you can tracing the you can recording what the application is doing on the client. Then the customer can send that tracing report to us to understanding what application is doing. So the other thing that we see that now a lot of IO500 in the RFP, but it's not just run the IO500 run, but also just require run IO easy or MD test easy, or maybe some of the RFP just pick the number of the good the command line option from the IO500 because they are not using the caching, so the people really want the sort of the option for the their to measure their system on the RFP. So so now IO500 is now getting the more the standardizing the standardizing the tool for the to determine the storage system for the of the in the RFP. So let me share. Our remark on the achievement. So as I said, we started testing from. So initially the testing was the 2019, before the supercomputing. Then we want to try keep the hardware configuration as much as possible. But we upgraded the storage system the couple of times, but we didn't change the client or the network so on over the 4 years. So it's all the same configuration. Then so we want to continuously testing and the continuous recording to the performance result. So even though when we upgraded the storage system, so we more conducted to run the performance testing, the apple the testing, then we know which the score is the improved come from the hardware that's upgrade, or maybe Lustre upgrade, or the Lustre improvement, or maybe the other software improvement. So we know that exactly which the score is so why each score is improved. But I don't want to explain all of them here. But it's two important things. If you can look at if you look at the first initial result and the final result that we got this year, so that is the over the much higher the performance improvement than what hardware upgrade can do. So that means that so all of the the performance improvement from the outside of the hardware upgrade. That means that the Lustre software innovation or Lustre software improvement. So the other thing, so that when we continue to run the testing, so this is very good. Then we know. So that's the continuous testing is very helpful. So we can understanding so how how the performance improved. Then we know what's the next objective for the next run. So the much easier to the understanding so the next target to the improve in the Lustre file system. So yeah, so in the software the performance engineering work. So this is the good the life cycle. So as I said, that when we run the IO500 run, then understanding the system of the Lustre behavior on the bottleneck, then sometimes we have to minimize the configuration to more narrow down where the problem is. Then after that, the more the deep dive in the bottleneck is, then sometimes the Lustre limitation or the other or bottleneck was the hidden, then now the exposed because of the new hardware that come up, or maybe so we didn't much investigate that area because of the IO500 is new the challenge for us. So now, so this is so we just realized that we have to investigate in that area for the that next another other the workload. So once we identified where the bottleneck is, then so we started the prototype work, prototype work to address the performance challenge. Then we run the IO500 again. Then show the good demonstration for the next submission. Of course, this is just the prototype work. Then to demonstrate the performance demonstration of the performance. But in the end, so we have to do the more full regression testing, the review on the merge to the upstream the Lustre, so as usual. So that is eventually. So we started the investigation from one of the performance limitation, but eventually so that that improvement that contribute to the Lustre, our customer or the Lustre community or the Lustre user. So some of the cases, the customer need help to test on that capability on the large scale system. Then if we need some tuning, so we do. But it's now, so it's a really good cycle for the performance work. So it's always takes a time, but that's why so we started the test investigating that work on 4 years ago. Otherwise, you have to wait to 2 or 3 years, to get that in the future. So now we are keeping the improvement with this cycle. So let me share the some of the critical the Lustre future. So we improved last couple of years. So as you already know, then maybe so as you already using in production. So Lustre overstriping the help for the single shared file overall. So in order to get a good single shared file performance, so you typically use the Lustre striping. So this is also good, but if the number of the process, but the number of the stripe count, the limit up to the the OST count before. So that is good. So that if you have your process is the same as the OST count, so you can get the good performance. But typically, so your number of the process is much higher than OST count. So in that case, some of the process is writing the same OST object, same OST. So that's cause some conflict. So it's good to manage on the that conflict with the lock. But there are a lot of lock ping pong between the server and the client. That's the cause of the performance problem. So the overstriping allows number of the stripe count beyond the OST count. So you can also configure the stripe count as the process count. So in the end, so you can so in the end, so each of the process is writing to different OST object, even the same OST, but it's no conflict. So you can see on this result here. So this is not the IOR hard, but the 1 megabyte of the shared file. So we see the same problem, but after the 500 after the overstriping enable, so you can we got the significant performance improvement with the overstriping. So next feature is the read ahead. So the Lustre is already implemented the read ahead a long time ago. So that very works well on the sequential read. But the IOR hard IOR hard, that is a straight to read. It's not the sequential read. So the previous, the traditional, the read ahead cannot detect that IO pattern. But after that, I fixed the improved read ahead detect straight to read properly. Then also the other problem was so read ahead it was managing there read ahead the window size based on the pages, the page sizes. But we also change the byte offset from the page index window size management. So because of the IOR hard, so this is not aligned IO. So 4 kilobyte or the page size cannot match that's the non-aligned IO size. So we saw that a lot of the many small page RPC, but then after the patch, so that we saw that a lot of avoiding a lot of the small page RPC. Then we also avoiding the read ahead window reset. So that's the improved read ahead the cache hit rate here. So let me share the result. So IO the easy read. This is sequential read, so it's always good as expected. But the IO hard read. So before the patch, there was Lustre 213. So the performance was really bad. But after the patch on the Lustre 14, so we got 12 times the speed up. So even though you can check on the the read ahead stats. So the previous result was we saw a lot of the cache miss. Then it's only the cache hit rate was the 9% for IOR hard. But after the patch and the read ahead, the cache rate improved over the 88%. So we read ahead the predicting so then prefetching the data. So what's the client really wants next. So the final, the future, so this is Andrea, so it's already presented in the previous presentation. So read ahead, the mechanism, the one of the, good capability on it's also the very extendable to the future of the metadata performance improvement. So in the past, the client triggered the read DIR, then the client sending the a lot of the stats, but that is one by one operation to the server. Then we see that a lot of the latency on each of the time. You can imagine if you have 1 million file on the single shared directory, then you see that 1 million the stats RPC to the server. So after the batch the operation is available, so the same read DIR, but the client can aggregate the stats operation, then store into the one single RPC. Then client can send the big RPC to the MDS. Then so we can significantly reduce the RPC latency between the client and the server. So you can see the result before and after the patch. So both of the MD test easy stat and the hard stats improved over the 2 times. So the additional Lustre performance enhancement. So this is also the Andreas presented. So we finally have automated the MDS balancing. So we are using the Stripe directory or MD test easy as well. But after that, this feature is available, so we switch the MDT on the auto balancing. Then we can avoiding the Stripe directory overhead. So that's also the improved performance. Then metadata overstriping is also the coming. This is a similar concept of the OST overstriping. But this is for the MDT. So MDT, the stripe count can be beyond the MDT count. Then we can also reduce the contention in the MDT. So the other tips on the performance improvement. So as I said, find the so the find operation that allows using the external tool for metadata scanning. So we developed a new tool. Then that tool, the scanning the MDT device in the directory without the client. Then so after that we got 7 times the performance improvement compared to the pfind. So this is not a tool for IO500, but we are shipping that tool as the one of the exascaler the component. So that's the alternative tool of the LFS find on the find command. So always a new kernel that help the performance improvement as well. So we started testing the Red Hat 8 kernel, but after the 2 years, we switched the Red Hat 8 server. So that also just server upgrade. we got the, over the 25% metadata performance improvement. So client side also that we started testing the Red Hat 7. Then so the performance limit the MD test hard start because of the the VFS didn't allow the parallel lookup. But after the kernel updated by Red Hat 8 kernel, Red Hat 8 distribution, so that's the speed up the start operation. But there's still some performance limitation in the VFS with parallel modification to the shared directory. So Neil Brown, the SUSE, submit the proposal upstream the kernel to allow the parallel update in the single shared directory. But the patch is not accepted yet. But hopefully, so we can get that patch soon. That's also the help on the Lustre. So the meantime, so we are using the multiple mount point in the container from the client as one of the workload. Let me share the quickly. So multiple mount point of the Lustre. So Lustre allows the multiple mount point on the single client. So there's many use cases on the security reason or the performance improvement on the very large client. You have to change some of the Lustre parameter because of the some parameter based on the system memory, but without that usually that works very well. So how we enable the multiple mount point IO500? So we just mount the same file system on the different mount point. Then you can just configure the IO500 configuration file. Then I just use Singularity as the container image. Then each of the container has associated with one MPI rank. Then each of the MPI rank is bind mount or each mount point. Then eventually different each of MPI rank does I/O through the different mount points. So that's you can get the full metadata performance from the client. So this is a summary. As you see, the Lustre performance has been proved. Large the production systems already. But the IO500 is the one of the benchmark metrics. Of course, there are a bunch of workload in production, so we know about that. How they also the large system is not only the performance, but also the high RAS capability of the future. So a lot of the other file system the capabilities is not needed. This is not not just run IO500 run works, but you have to be careful. System have to be stable. Then have to demonstrate the same performance in the production system. But on the other hand, so IO500 they opened the new door. Then they give us a lot of the new challenge. Then opportunity to understand, opportunity to improve many of the many of the performance improvement in many areas. So finally, so what's next? So we are now number of the effort is working for the IOR hard write. So the Patrick will present tomorrow. So the I/O support for aligned I/O. Then we also have delayed allocation to the server side. So both of them to improve the IOR hard write the performance. Then also we implement the batch to start the future. So that's the future also the extendable for the read as well. So hopefully so that once we can implement it, the cross-file read ahead with the batch, the RPC in the framework. So we probably see metadata MD test hard read performance boost. So that's also the help on the small file read workload. So that is a good thing. As I said before, so that so upgrading the kernel on the server is very improve the performance. So that's also the encouraging the trying the Red Hat 9 kernel on the server to see the any the performance improvement. So that's all. Thank you.
Thanks. So as we are short of time, buses are waiting already. Maybe a quick question? Someone? Yeah, okay.
I may just have missed it, but you had those performance evaluations over time, and there was this MDT status test, and it showed an improvement by 4 orders of a magnitude, by a factor more than 1,000, right? So it was the yellow slide, yeah. And what is the reason for that? But it says 54 times quicker, right?
For that
MD test hard stat.
Oh, hard stat. Where is that? That one.
Yes.
Yeah. So the reason why, because of the 2 reasons. The one is the old kernel using on the client, so the new kernel on the client to improve the performance. But the other thing, at the beginning of the testing, so we didn't use the multiple mount point of the client. Then after that, we optimized the Lustre configuration. We enabled the multiple mount point of the client. Then that's the boost of the performance. Of course, the start ahead, from the Lustre, the new feature, also the contribute. It's a multiple, the future is improved.
Okay. Thank you.
Thanks a lot.